This is Dr. Carroll, and this video is about calling methods. Then when we call a method, we're passing arguments to a method, but we need to keep in track of what is the data type that we're passing, because the two different data types have different mechanisms of how they work. So let's step through each one of them. First, a primitive or simple data type. So with the primitive data type, so we're talking about ints, chars, booleans, floats, double, those sort of things in a method call, then what we're going to do is we're going to copy that value as is over into the new into the parameters value. Okay, so let's see an example here. So if we had a simple main where we have value, and so it's an int, so it's a primitive data type, we've assigned it to 1, but if we make a call to change params and pass it in there, it's going to take that 1 and it's going to copy it into the parameter here, num. And I've named them differently to keep track so we could talk about them very clearly. So it's going to copy 1 into num here, and so it will make a copy of that. So if we did something like num equals 42 here, it has changed the value of num, but it has not changed the value of value. Okay, and so that's what happens with the primitive data type, and this is called a pass by value. We're taking value here, we're copying it into num. Now let's talk about reference data type arguments. So if we have a reference data type, so you could think a string, an array, they do interesting things, or if we've created a new object, we've instantiated one with new and then the class name, etc. If we have some sort of reference data type and we're using that in the method call, then what is copied is the references value, which is a memory location. So where is it pointing into memory, or more explicitly into the heap? So that reference is copied. So let's see an example of this with some code. So taking the same code as above here, let's add in a reference object. So individual here is a reference object of type simple person, and we are instantiating it, calling the constructor with just Cody. Let me pull up that code real quick so that we can see that. Simple person Java. So here we have a simple person. It's got 2 instance data, a name and a color, person's favorite color, and we're instantiating. We can call a constructor with its name. That's our only choice. We have get name, get color, set name, set color, and a toString method. Pretty simple, pretty straightforward. Okay, so let's go back to the example here. And so here we have we've created a new individual. So value is a primitive data type because it's int. An individual is a reference to an object of type simple person. And so now if we change this so that we add simple person to the change parameters here, and we could do something with that, for example, call set name on there and change Cody to Cody Cougar, give it a new string here, and then we can call it passing an individual as well. So now value here, whatever this value is, which is 1, we're copying that into here, and we're copying individual into person, but what we're copying is a reference. We're copying a reference to this simple person object. So now let's talk about stack frames and heaps and what's going on, and then let me show you an animation that hopefully will make this more concrete even still. And so when a method is called, we put those arguments on the stack frame and copy in those values. So let's look at an example here. So let's take what we've been working with before and let's add in some print statements so that we can really see what's going on. First, let's put in a print line statement here that is showing the parameters and their values right after it's called, and then let's do it at the end of the method too. And then what's going to be most interesting actually is the print line statement after the call to change parameters. Okay, so we haven't changed anything, but so let's see this. Let's compile this here, and then let's run it. And sure enough, so num is at the beginning of change params. It's a little small. That num here is 1, and the name here is Cody. We can't actually get at the private data member, but that's what it is. We're using get named. I just want to make sure that's clear here. But then notice at the end of change params that num is changed to 42 and the person name is changed to Cody Cougar. And then now in main, notice value is 1, it's not 42, but the individual name is Cody Cougar. So let's see what's going on here in the code. So here we have our stack frame, and as we call, let me flip back to the code, as we call main, then it's going to put this on the stack. Okay, so this is the stack frame, this is the part for main. It's going to put args because that was a parameter, and then it's going to put value and individual on the stack frame, and then we're going to assign 1 to value, and individual we have it calling new simple person, and in there it's creating a string and we're assigning it to Cody. Okay, so that's a couple steps here all in one, and so that corresponds to these 2 lines having been executed. Now when we go to call change params, it puts num and person on the stack, and this is due to change params, and then we copy in those values. So we'll copy 1 into num, and we'll copy the value of individual into person. Well, its value is this arrow, it's the memory location, so it's referencing this simple person object, and so that's why we have a copy of this arrow going to the exact same place, the exact same object on the heap. So now that is showing the call to change params and that we've set up the parameters and assigned them. Now when we go to assign 42 to num, notice it changes num, it doesn't change value. It changes num here, and we have just copied in this value, so it's just a copy, and so we've changed a copy of it. And now when we call person set name, we change that to Cody Cougar. What that does is that creates a new string and assigns it to name. Notice it's a new string and assigns it to name. So I've grayed this out here to indicate that garbage collection is going to come around sometime and clean up that object. We don't know exactly when, but we can't get at it because we no longer have a reference to it. And so that illustrates this line of code here, the set name. Now what's interesting is when we're done with change params, which we are, then it's going to pop this off the stack and it goes away. And notice value is 1, it was never 42. Individual is referencing the simple person, and name is still referencing Cody Cougar because we changed the object in memory. Okay, so notice the difference between the private data member and the primitive data type and the reference data type and how they're different. Now let's do this example again here, but with just one little change. Instead of set name in change params, let's change that to simple person. Let's make a new simple person object and do that. Okay, so Let's step through an animation here of this one. So the beginning is going to be the same. We call main. It puts the parameter on the stack frame, and it also has our local variables here, value and individual. We assign value to 1, and we create a new person object that has Cody. This is all the same. We call params just like we did before, and we copy in value and assign it to num, and we copy an individual so it references person. Now this is where it gets interesting. So now we assign 42 to num, and again it doesn't change value. And we also, but now here person, we are reassigning it to a new simple person. So when we call new, we are creating this new object here, and its name is Cody Cougar. Okay, and so person references this one, and notice it doesn't reference this one, and especially notice individual still references heap in the heap the simple person whose name is string Cody. So now when change parameters is done, okay, and I'm just skipping over the print line statements. When it's done, we pop it off the stack, and these are in memory, and they're going to be cleaned up by garbage collection. That's a technical term. And notice individual here is referencing the original one, and it's untouched because when we called new and it assigned it, we changed this variable, what it was referencing, but not this one. And so when I took the time to make this diagram to show you the difference there and assign it. Let's run this code. Yay, it compiles. And sure enough, okay, when we call change params, just as before, it's 1, and then the person name is Cody, and then after it, it's changed, but this is where it differs here. Individual.name is still the original one as was passed in here. Unlike here, we changed it by calling that object's set name. Here we created a new object, well, that one's gone when we're done with the video. When is gone when we are done with change params. Hope this was helpful to understand the difference between having a primitive data type being called and what happens, and having a non-primitive data type and what can happen there. Hope you enjoyed it.